Hi everyone. So today I'm starting a new chapter. This doesn't mean that I'm not going to be doing problems from the old chapter, but I'm just going to mix them. I'm going to do some from chapter 3, some from chapter 4, just because I thought it's about time. Anyways, before I get started, with the actual problem, I was wondering if you find my videos helpful, if you think they're useful, if you like my videos, please don't forget to like and subscribe. It's one of my goals to maybe hit 500 or 600 subscribers by the end of this year or hopefully November. So it would mean a lot to me if you did that. If you don't like my videos, then you don't have to do anything. But if you like them, then please go ahead and do that for me. Thank you so much. Okay, so I'm starting the forces chapter. I want to make it clear that this is problem 2 from Young and Freedman's University Physics textbook, meaning this is not my own work. I do not own this problem, but the solution that I'm presenting, I did come up with it on my own. So that's my own work. All right, so now that that's out of the way, let's get started on the actual problem. To extricate an SUV stuck in the mud, workmen use 3 horizontal ropes, producing the force vectors. A, find the x and y components of each of the 3 poles. B, use the components to find the magnitude and direction of the resultant of the 3 poles. So this question is actually really easy. It's one of the most basic type forces problems. And I think that's why it's a really good one to just start with because then we can work our way up to harder stuff, because the harder problems we're going to have to do all these steps, but also all everything that question requires as well, right? Like the difficult problem, the more complex steps that we have to do those in addition to these. So it would be really great if I just had one video detailing everything in detail of how to add vectors together, how to use components to find the magnitude and direction. Okay, so now that we already have a diagram, I don't have to go ahead and draw one, but let me just go ahead and just talk about it a little bit so that we're really clear when we write down our knowns. Okay, so clearly here we have this XY chart, right? Or this XY Cartesian plane. And we're given this X right over here, and we're given this Y right over there. So we want to find out what the X and Y components are of these 3 poles. So let's talk about it. What does it mean to have an X and Y component when we are dealing with these types of problems? Okay, so let me bring out my favorite color, pink. Speaking of pink, did any of you guys watch the Barbie movie? Because months in advance, I heard that there was going to be a physicist Barbie, and there was a Barbie who won the Nobel Prize in physics. And I was so excited because I'm like, oh my God, physicist representation, like women in physics. And I love the Barbie movie, don't get me wrong, but I was a little disappointed that she didn't talk more about being a physicist. It was really just, yeah, I won a Nobel Prize and that's it. It would have been really cool if she talked physics for a bit, or yeah, I don't know. Anyways, back to our problem. So pink. Okay, so let's say that all of our X components are going to be with pink and all of our Y components are going to be purple. Okay, so this, starting off with this one right over here, this vector that I just circled the magnitude of, this would be the X component, right? And we can see that that X component is, if we set, okay, before, sorry, I actually should have mentioned this first, but whenever we have a Cartesian plane, one of the things that you guys might have noticed that I like to do is set up what's positive and what's negative, right? Because it's important for when we add vectors, right? We need to know what's up is positive and then down is negative, right? And then right is positive and left is negative. In this case, positive X is going to be pointing this way, and positive Y is going to be pointing upwards. Okay, now that we've made that clear, it will make sense what I say about this pink X component right over here. So this is going to be in the positive X direction, right? So it's really just a projection of this vector. Okay, what else? We also have this X component, right? It's a projection of this vector, but it's in the negative direction, right? So if we were to add these 2 vectors together, we would do this vector minus this vector, right? That makes sense. Okay, now what about this third one? So we have 788, right? And we also have this x component right over here, right? Because that's like the projection in the x direction. And we can see here that this is negative, right? So this is pointing in the opposite direction. This arrow goes that way. So we're going to be subtracting this from this as well, from this x component as well. And while that sounds like a little bit abstract, or some of you might know exactly what I'm talking about, we're gonna write it all down and it's gonna make much more sense. But for now, just try to understand what I'm saying about the diagram, right? I'm gonna go over it again when I write down all of our knowns. Okay, so this y component, or how do we add all of the y components for all the poles? Okay, this is gonna be the y component. This is going to be the y component, and this is gonna be the y component. So as you can notice, this is positive, but this is negative. So we're going to do this plus this minus this, right? That makes sense. Okay, so now let's actually write down how we would write down all of our knowns for this type of problem. Okay, so what I like to do is I like to create a chart. So let me do that. Let me create a chart, and I'm going to do it in black. So just like that. Okay. This is x, and this is y. Okay, so for x, let's number our vectors. So let's say that this is vector number 1, this is vector number 2, and this is vector number 3, right? Each one's in a separate quadrant. Okay, so what we're going to do now is we are going to write down the x component, and then we're going to put a plus or minus depending on, sorry, there's a purple line here, but it's bothering me. See, that's so weird, this eraser. Like, I was erasing something else and it just erased that entire black line I had, I think. Okay. I think that's what happened. Okay. Anyways, and the first line was so straight too. Okay. Anyways, so now we have purple or pink again. And we just want this x component, right? So we want this right over here for 1. So for 1, we have 985 cos 31, right? So if we do cos of 31, we end up with this projection, this pink projection. It's gonna be 985 cos 31, right? And it's positive, right? So I can write a positive right over here just for the sake of like teaching you guys right now. But like when you're actually doing these problems, you don't have to put a positive sign there. You can just leave it as, you know, negative. Or not, sorry, no, not negative. Unless, let me rephrase that. Okay, unless it's negative, you don't have to put anything. If it's a negative, then put a negative sign. If it's a positive, you can put a positive, don't put a positive, nobody really cares, okay? It's your choice, it's about whatever your preference is. Okay, so now we have y component. And y component, I'm going to do it in purple. So this component right over here. And this one, it's upwards, so it's positive, right? So it's going to be 985 sine 31. And one trick, my high school, okay, so my grade 11 physics, no, my grade 10, no, okay, this is so long ago. But yeah, my grade 11 physics teacher told me that like sticks to me like till this day is when you're doing these component questions, always use this rhyme. Cos is close, sine is the other line. What does that mean? Let me just write that down. So cos is close, sine is the other line. Okay, cos is close, meaning that the line that is like close, like that's attached to the vector, that's cos, okay? Cos is not always going to be x. The line that's closest to the vector, that's cos. Sine is the other line. The other line that's like not touching the base of the vector, that's the other line. So that's going to be sine, okay? Okay, so now let's move on and do the second one. So for 2. So for 2, x is going to be this direction, right? That's going to be the x component. So in this case, it's going to be 788 sine 32 to get x, right? Because this sine is the other line, right? So it's not attached here, it's the other line. So it's going to be 788 sine 32. And it's not positive, right? So it's this direction would be positive x, but the direction that it's going, this is negative. So this is going to be minus 788 sine 32. Okay. Now for the y. Now for the y, let me just grab my purple pen. Okay. So now for y, it's going to be this. This is the vector. Okay. And this is the one that's close. So 788 cos 32, right? Because cos is close, and then sine is the other line. Now, is this positive or negative? Well, it's pointing in the upwards direction, and we established that upwards is going to be positive. So this is going to be positive. Okay, so now for vector number 3, writing that down here. Let's write that down there. Okay, vector number 3. We have this right over here. That's our cos component, right? Because that's like, this is, this direction like is x, right? So this is x and this is x, right? So this is the x component. See, it just did it again. I was erasing it down there and it just made the 2 disappear. Okay, this is a Zoom bug that I don't like very much. Okay, so yeah, now we have this x component right over here, but what is it? Okay, there's 2 things we can do. So one, we can see that this, because this is 90, we can do 90 minus 53, right? And that's going to be 37, right? Can't do simple math. Yeah, 37. I hope that doesn't erase everything. Okay, good. 37. Or it's better if I draw x as this right over here, right? So we're given this angle, so it's better if I draw x as that. So that is the x projection, right? And that is, because it's the one that touches the tail of the vector, that's going to be 411 cos 53, right? And this time it's not like positioned in the positive direction, it's pointing this way, so it's negative. So it's minus 411 cos 53. Okay, now what about y? Now this is the y component. And the y component is going to be 411 sine 53. And again, it's pointing downwards. So downwards is negative. So there we go, that's downwards. So sorry, what was this 37 thing about? Okay, so there's two things we could do. We could do, again, this is kind of like off on a tangent, but like pay attention if you want. If not, just fast forward. or yeah, double speed this, I don't care. Move it forward if you don't want to hear this. But if you do want to hear this, if we have some sort of like right angle, right? Like, let me draw it. Right angle that looks kind of like that. So we have 53 over here. And this is going to be 37. So really we can use both. We can say that, okay, this, you can use, if you want to find x, let me use pink just so we can match what we were doing already. So if we have x right over here, we can use cos 53 to figure that out, or we could do sine 37. Right? Or cos 53. Okay? So both of them are going to give us the exact same answer. Yeah, in fact, they're equal to each other, right? So cos 53 is equal to sine 37, and like vice versa is true too, right? So sine 53 is equal to cos 37. So really it's just a matter of like how you drew it out, but both will give you the same answer. That's the beauty of math. That's why I love math. Okay, let me just erase this without making this thing go crazy. Okay. All right. So now we want to find what the x and y components are of the three poles. We did that. Okay, now what are the resultant x and y components? All we have to do is add these together, right? So we're just going to do addition. And by addition, I mean, 985 cos 31 minus 788 sine 32 minus 411 cos 53. That's what we're going to do. We're going to add the x and the y together separately, right? So we're not going to add x to y. We're going to do x separately, and then we're going to do y separately. And I'm just going to double check on my calculator just because I don't want to make a mistake and have to re-record again. As you guys may know already, I hate re-recording. It's such a hassle. Oh, and the only thing I hate more than re-recording is editing. So I would actually much rather re-record than edit something. Okay. Anyways, so the final component that I got, or like the result of the addition, is 179.387. And then for y, I'm getting 847.335. Okay. So, yep, that's what I got before as well. So that checks out. So all together, if we add all of our x's together, then we get 179.387. If we add all of our y's together, we get 847.335. So now use the components to find the magnitude and direction of the resultant three poles. Okay, so one thing we can notice is that both of these values are positive, which means that they're going to be in this direction and in this direction, right? So in this x direction and in this y direction. If they were negative, then they would be pointing downwards or leftwards, but they're not. So now what we're going to do is we're just going to pick some point just like that, okay? And what I'm going to do now is I'm just going to draw something that represents 179.387. And that's going to, I'm going to draw like a little tip there, okay? And now we're going to do tip to tail, and we're going to draw or 847.335. Okay, just imagine that, okay, I'm going to redraw that, yeah. But just imagine that this goes exactly, there we go. I drew it well this time. Okay, so now we're going to use Pythagorean theorem. We want to find out what this resultant vector is, right? So to find this, so let's just call this x, right? So x is equal to Pythagorean theorem, so 847.335 squared plus 179.387 squared, and then we're going to square root the entire thing. And that gives us, just going to plug into my calculator again. Yeah, that gives me 866.1158 or 59. So just depending on, how specific you are, you should get approximately this answer. Okay, so that's the magnitude of the final force. What about the direction? Okay, the direction, we're just going to look for this angle right over here. So this angle, let's call it theta, and I'm just going to use a different color so that we can see it a little bit better. So let's make it blue. So this theta is going to be equal to the tan inverse of opposite over adjacent, right? And from that, I am getting, plugging into my calculator again, 3, 8, and 4. I'm getting 78.05 degrees. Okay, so the magnitude and direction, well, the magnitude is 866.1158 newtons, right? Because units, we have to have units. And then it's going to be 78.05 degrees above the x-axis. Or above the horizontal, whatever you want to call it. Okay. So yeah, that is our solution for part A and B. I hope that was helpful. And as I always say, if you have any questions, please don't forget to leave them in the comments. Please don't feel shy to contact me by my email. And yeah, I'm always happy to answer your questions. If you have any requests that you would like me to do, I will be happy to do those questions and upload a video, but you just have to be specific about which question it is and give me the final answer, because I don't want to help anyone cheat. I feel like that's just kind of unethical personally. And yeah, if you found this video helpful, please don't forget to like and subscribe. And yeah, see you next time. Thank you so much for watching.